Hello everybody and welcome back to the Leetcode grind. Today we have 2037 minimum number of moves to seat everyone. It says here that there are n seats and n students in a room. You are given an array seats of length n, where each seat at ith position is the position of the ith seat. You are also given the array of students of the same length n, where each student is the position of the jth student. You may perform the following move any number of times, which is to increase or decrease the position of the ith student by 1, like for instance moving the ith student from position x to x plus 1 or x minus 1, and we are to return the minimum number of moves required to move each student to a seat such that no two students are in the same seat. Note that there may be multiple seats or students in the same position at the beginning. Okay, so the problem is initially seemingly complex, but essentially what we're getting are a list of seats, and this is each seat represents their position in, let's say, some row, and we're also given a list of students. And we're only trying to rearrange so that each student is in a seat that is available. And we're trying to do that with the minimum number of moves, where a move is just basically the difference between where the student currently is. Let's say I'm a student, I'm at position 2, and I want to get to 3. That takes 1 move. To get to 1, that takes 1 move. To get to 5, that takes 3 moves. Notice that 2 can go lower or upper, so that hints at that we will be using some absolute of some distance. Okay, so let's kind of get through an example. So we have our, so these are our seats, okay, and these are our students. No, these are our students. Okay, so right off the bat, it seems pretty intuitive that the best way, or the easiest, not the best, the easiest way to optimize for the least amount of moves is just to order these first. So that's 315, that's going to be 135, 274, that'll be 4 and 7. Okay, so then we're gonna have to seat every student, and by ordering them both, we have the best chance of using the least number of moves to seat each student, so that we're going to be comparing these two, and these two, instead of comparing 2 against every other seat available. Okay, and at each seat, all we take is the absolute difference between the two. So here that would be 1, here that would be 1, here that would be 2, and return the sum. And that's pretty much it. We can take another example here, just to prove that it does work. So 1, 4, 5, 9. Okay, so we're going to do 1, 4, 5, 9. The students are 1, 3, 2, 6, so that'll be 1, 2, 3, 6 when you sort this guy. And all you do, once again, is just to take the difference. So here, there's no difference. Here, there's 2. Here there's 2, here there's 3. You sum that up, 3 plus 2 is 5, plus 2 is 7, and that is our output. And that's pretty much it. So let's implement that in code. We sort the students, we sort the seats, so they're against each other in order, and we initialize the moves to 0. I'm just going to make it rows to 0, and then all we do at this point is, for I in range of the length of seats, and these two have the same n value, we're going to say res plus equal the absolute of the difference between where the seat is and where the student is. And at the end, we return res. So sort both of them so that they line up, and we know this is the lowest This is the second lowest, this is the third lowest. We know that these line up, and we initialize the counter and then iterate every pair and add the absolute difference as the distance to get to that pair and return a result. Give that a go and give that a submit. And there you have it. We have 2037 minimum number of moves to seed everyone. Thanks so much. Happy coding and see you next time.